Warm greetings to all the participants who have joined us in the second part of our lecture on representation of data. I am Dr. Shweta Sharma from Department of Botany, Gargi College. In the first part, we introduced you all to the importance of summarization and ordering of data. We also discussed the steps which are involved in preparation of a frequency distribution table, which in turn is extremely important in ordering a raw data. Now let us continue our discussion on representation of data. The two most important and widely used method for data representation are diagrammatic, that is with the help of diagrams, and graphical representation, that is with the help of graphs. The second part of our lecture will be focused upon diagrammatic representation of data. In this section, we will be dealing with the importance of diagrammatic representation of data. We will also study the different types of diagrams which are popularly used for representing the data, and we'll also learn how to draw the different types of diagrams. The importance of diagrams in representation of data can be very aptly expressed with the famous quote of M.J. Moroni that goes, "Cold figures are uninspiring to most people. Diagrams help us to see the pattern and shape of any complex situation." It is true that diagrams do not add any new meaning to the already existing statistical data, but they definitely help in deciphering the data much more clearly and quickly. We all must have noticed that when we look at the numbers given in a table, it becomes very difficult and sometimes confusing also to comprehend anything out of it. So here comes the importance of visual representation of data. Now, a very obvious question that comes to our mind is that why should I use diagrams for data representation? If I already have my data in the form of a table, what benefits am I getting from representing it with the help of a diagram? The answer is yes, there are several advantages of representing data with the help of diagrams. First thing, diagram represents the data in a form that is much more conducive and simpler for the readers to draw inferences from. Diagrams also are a very good way of giving an attractive and visual appeal to the data that is being represented. Diagrams also facilitates easy comparisons of different data sets at just a single look. Also, diagrams are very helpful in simplifying very complex data sets also. So sometimes you must have noticed that in a table, several different factors are taken into account, and that makes the data very, very complicated. And just by looking at such a data, it becomes very difficult for the readers to draw inferences from. But if such a complex data is represented with the help of very simple diagrams, so that becomes easier for the readers to draw conclusions from such a diagram. Now, before we move ahead with our discussion on different types of diagrams and to learn how to prepare such diagrams, it is very essential for us to understand that there are some general rules that one must consider before drawing a particular diagram based on a data set. So we'll discuss the important points one by one. First thing, the diagrams must be geometrically accurate. That means that they must be drawn on a graphic axis, which is an x-axis, which is the horizontal axis, and a y-axis, which is the vertical axis. However, in most of the cases, diagrams are generally drawn on a plain paper, but the scale is always kept in consideration. Also, it must be ensured that the scale which is being represented on the x and y axis is appropriate. This actually means that in a manner which is very easy to represent. So the scale in most of the cases, it can be in multiples of 2, 5, 10 or 20. Also, a short and self-explanatory title must be given to every diagram, and that title can be written at the top of the diagram or the bottom of the diagram. So with the help of this title, a reader who do not know any information about the background of that particular data is able to understand the context in which that data is represented. Also, the diagram must be attractive and proportionate. That means the diagram should not be very big, should not be very small. Also, we can use different colors, patterns, or shades to represent different components of a diagrams. So it becomes very easy for the reader to differentiate between different components in a single diagram. Also, if we are representing different components, then an appropriate index must be provided for easy identification of the different components. Last but not the least, it is very important to choose a suitable type of diagram for your data set, and this choice, it depends upon the type, a number of factors actually. That is, what is the type of variable, what are the number of variables in your data, what is the minimum or the maximum value. So keeping in mind all such factors, you will be able to select most appropriate diagram to represent your data. Now, coming to the different types of diagrams that are commonly used for representing the data, as is visible from the given diagram, there are three major types of diagrams: line diagram, bar diagram, and pie charts. The bar diagram is further subdivided into four types: simple bar diagram, divided bar diagram, percentage bar diagram, and multiple bar diagram. We'll start with each one of them. So starting with the line diagram. Line diagram is the simplest type of the diagram which is used for representing data. For diagrammatic representation of data, the frequencies of discrete variables can be represented using a line diagram. So in a line diagram, the variables are represented on the x-axis, and the individual frequency of each variable, it is represented on the y-axis. So this representative line diagram is given here. Here you can see that it is actually a diagram to represent the income of 10 workers. So on the x-axis or the horizontal axis, the different number of workers are taken, and on the y-axis, income in rupees. So on the x-axis, you can see that each one of the worker is represented as a single entity. So 1, 2, 3 given by these numbers, and on the y-axis you can see that income in rupees. So for every worker, the income in rupee is represented by a straight vertical line. Okay, and from this fact only, this type of diagram is called as the line diagram, because straight vertical lines are used here to depict the frequency or the number of observations that are there for each category of data. So let us understand the line diagram preparation with the help of the given data set. This is a data which is concerned with area under forest cover in Delhi for the year 2009 to 2019. So in this table, you can see that there are two columns. One is for year and one is for area under forest cover in square kilometers. So using this type of data, let us see how we can draw a line diagram. Okay, so on your right hand side, you can see a line diagram prepared from the given data. So first thing I must mention here, that the line diagram can be represented in the form of vertical lines or horizontal lines also. So here you can see that this is a diagram where horizontal lines have been used for the line diagram. On the other hand, the previous line diagram that we saw, it was straight vertical lines. Okay, so both ways it can be presented. So here, if we look carefully on the vertical axis, on this axis you have the different categories of data being represented. So you can see here what are the different categories. Here in this case the different years, individual years are the different categories. So 2009, 11, 13, 15, 17 and 19, which are the respective years in which the data has been collected. Okay, so vertical axis here we have the different category of data, and on the horizontal axis, the exact value of the observations that were taken in that particular year. So on the horizontal axis here it is the observation, or it can be the frequency taken for every category of data. Okay, so in this type of line diagram, particularly the horizontal type of line diagram, on the vertical axis category of data can be represented, and on the horizontal axis the actual value of the frequency, or the observations for each category of data that can be represented. Okay, so on the vertical axis, for every year a horizontal line has been drawn, and the length of the line is proportionate to the value of the observation. So here you can see for 2009 the area under forest cover is 299.58 square kilometers. So a horizontal line proportional to the said observation has been drawn here to represent the exact value of the data. Okay, so with the help of such a diagram we can easily represent the different categories of data, also different frequencies observed for the variables under consideration. Again, one thing I would like to emphasize, that the lines can be drawn either vertical or horizontal. Also, there should be uniform space between the consecutive lines that are being drawn to represent the different categories of the data observed in each case. Starting with the second type of diagram, that is the bar diagrams. Bar diagrams are one of the most commonly used diagrams to represent data in the case of statistical data, or for that matter any research based data. Bar diagrams are also called as one-dimensional diagram. This is because the reason that only one characteristic of the bars, that is the length of each bar, is variable or can be varied in a particular case, and not the width. Okay, so only because one characteristic is important, these diagrams are also called as one-dimensional diagrams. Now again, the bar diagrams can be drawn horizontally or vertically, that is with the help of horizontal bars or vertical bars, as we had discussed in the case of line diagrams. Now, two things I must mention here that has to be taken care of while drawing a bar diagram. First point is that the width of each bar has to be uniform throughout the diagram. Okay, and the second important point is that we should make it very, very clear that the gap between the consecutive bars that are used for representing the data has to be uniform. Okay, so we can see these two important points with the help of this representative bar diagram that has been given here. You can see here that this is a bar diagram with vertical bars. Okay, and by bars we mean these rectangular boxes. Okay, so vertical bar diagram is drawn using vertical bars to represent each of the value corresponding to the category of data. Also, what can be deciphered here from this graph is that width of all these three graphs is uniform throughout the graph. So width of the bar has to be constant. Also, you should observe here that the gap between each of these bar is also kept uniform or constant. So these two things are extremely important while drawing the bar diagram. Now coming to the first subtype of the bar diagram, that is the simple bar diagram. A simple bar diagram is used to represent when in our data set only one variable is present. So that has to be taken care of. Again, simple bar diagram can be represented either vertically or horizontally, that is with the help of vertical bars or horizontal bars. Another important point that has to be considered here is a simple bar diagrams can be used to represent both positive as well as negative values. Okay, how? So in case the simple bar diagram is represented in a vertical manner, that is, it has been drawn in a vertical manner. So the positive values are represented on the upper side of the horizontal axis, while negative values are represented by drawing the bars below the horizontal axis. Okay, if we look at this given simple bar diagram, here you can see that it is a vertical simple bar diagram, that is the simple bar diagram drawn in a vertical manner, and you can also see that all the values are in positive you know direction. So the you can see the bars are drawn above the horizontal axis. So if we also had some negative values in our data set, the bars could have been drawn below the or lower the horizontal axis. Okay, now second condition can also be there, that what if our simple bar diagram has been drawn horizontally. So in this case, the positive values are taken on the right hand side of the bar, or and the negative values are drawn on the left hand side of the bar. Now again, the two important points that is very crucial in drawing a simple bar diagram is that first thing, only the length of the bars should vary, and the length of the bar should be in proportion to the value of the observation that is there for each category of data that is recorded, and the width of the bar should not vary. The width of each bar should be kept constant throughout the diagram. Also, the gap between the consecutive bars should be uniform or identical throughout the diagram. Again, let us understand with the help of the same data set that we took for our line diagram. This is actually data collected by one of our students while conducting the project research work for the biostatistic paper. Now here again, area under forest cover in between the years 2009 to 19. Now again, you can see here the bar diagram that has been drawn here. I will ask you to identify, and yes, it is a horizontally drawn simple bar diagram. So on the vertical axis, you can see the different category of data, and here categories are being represented by the individual year. So you can see from 2009 to 2011, 2013, 15, 17, and 19. And on the other hand, the horizontal axis is actually containing the values which are being represented by the area under forest cover observed for each of these different years. Okay, so if we draw the simple bar diagram in a horizontal manner, so on the vertical axis our different category of data should be there, and on the horizontal axis the value corresponding to each category of data should be depicted. On the other hand, if we are drawing the simple bar diagram in a vertical manner, so if we draw in a vertical manner on the horizontal axis, okay, on the horizontal axis our different category of data should be there, and on the vertical axis the values corresponding to each category of data should be represented. Okay, so now let us understand this by taking one example. So for example, if we take the year 2019, you can see the area observed or area calculated under the forest cover is 324.44 square kilometers. So you can see that on the vertical axis, the category of data, that is the year, is represented, and a horizontal bar is drawn, and the length of the bar is proportional to the value given here, 324.44. You can match it on the horizontal axis in square kilometers. You can also observe the fact that the width of the bars are kept uniform, and there is a constant gap between the each bar that is used for representing the value of observation or the frequency noted down for each category of data. And this is in fact the major difference between the bar diagram and histogram. That is, in bar diagram there is a uniform gap between each bar used for representing the different categories of data, while in histogram the bar, there is no gap. Actually, the bars are represented just in touch with each other, with no gap present between the consecutive bars. Now, starting with the second type of the bar diagram, that is the divided bar diagram. Divided bar diagrams are used in those cases where the frequency of a variable is divided into different components. So in divided bar diagram, one bar is used to represent the total value of one variable. Then this bar is further subdivided into various smaller parts, and each part now corresponds to the different components of the same variable. Okay, so again I'm emphasizing here the fact that one bar is used to represent a single variable, and this bar is further divided into various smaller parts, and with each smaller part representing the different component of the same variable. So with the help of this particular diagram, we are able to represent the total of the variables and also the various component of each variable with the help of a single bar. Now, because here the different components of one variable are represented with the help of a single bar, this kind of diagram is also called as component bar diagram or stacked bar diagram. Divided bar diagrams actually they are serving the same purpose as that of multiple bar diagram, but there is one major difference, that is, in case of multiple bar diagram, each component of a variable is shown side by side horizontally, but in case of divided bar diagram, the each component of a variable is represented as smaller sections within a single bar stacked one upon the other. Okay, now here is a representative divided bar diagram for your reference. You can see here there are four variables or four different categories represented by team 1, team 2, team 3 and team 4. Now each of this category of data is further subdivided into four components, that is four periods: period 1, period 2, period 3 and period 4, and it can be identified from the index given here, the color corresponding to each period. Okay, now you can see here that the values of different components are being represented as the subpart of one single bar being used for representing team 1. Okay, and the values are represented in such a manner that they are stacked upon one another or represented as different subpart of the single bar. Now there are a few limitations of divided bar diagram also. First limitation is that divided bar diagram can be used when total number of values of the variable is small. In case the total number of variable values of the variable are large, then it becomes very difficult to accurately depict each component in with the help of a divided bar diagram, because the scale becomes very narrow and thus each component is not depicted very clearly. Also, the second limitation is that because in case of a divided bar diagram, the subparts are represented as stacks upon one another and they are not sharing a common base, so a comparison between different components becomes slightly difficult. Okay. Now again, one thing I should mention here, like we discussed for simple bar diagram, divided bar diagram can also be represented both with the help of vertical bars or horizontal bars. Now let us understand how to draw a divided bar diagram with the help of a data set. This data set that is visible on the screen, it is concerning with the distribution of rainfall in millimeter in different months of a year in Delhi between the year 2009 to 2013. Again, this is the secondary data which was collected as part of the biostatistic project work by one of our students. So you can see here the these 5 years that are represented. Each year represent the different category of data, and further each category is being divided into several components which are represented by the months of the year. Okay, so 5 different variable, and each variable is again further divided into various components. So let us see how we can draw a divided bar diagram on the basis of this particular data. So you can see here that a horizontal bar diagram has been drawn on the basis of the given data set. Why? Because the values were large. Some of the values were quite large. You can see 214 and 130. So the horizontal divided bar diagram was a much more convenient way of depicting such a data. Now, let us try to understand this. Here again, all the 12 years of the month are being represented by different colors, which are very clearly visible as different subparts of the bars used for depicting each category. Okay. Now, let us see, for example, for the year 2011, you can see that the different values are being represented with different colors, highlighted with different colors as different sub parts of the same bar. So the single variable is represented by the complete length of this bar, and the different component of this variable are being represented as the different subparts of this bar stacked one after the other. Okay, so in this bar diagram, on the on the vertical axis, the various category of data or the variable is being represented and on the x-axis or the horizontal axis, the values of each variable is represented, that is the rainfall in millimeter. Okay, now if we look at this data, one thing I would like to highlight, because here each variable or each category is divided into 12 different components. You will notice that in certain cases all the components are not being depicted with clarity, and this is what I had mentioned earlier. So this will be a limitation. So when we have several different component and various values are there for each variable, then it would be slightly difficult. But you can also see here that you can very well see that the months like July, August and September are the months where maximum rainfall has been observed in a particular year from 2009 to 13. So again, it can act as a very good way for comparison between different category of data simultaneously. The third type of bar diagram is the percentage bar diagram. In a percentage bar diagram, the length of each bar is kept equal to 100. Okay, that is reflected in the name itself, that is percentage bar diagram. Then each bar whose length we have kept as 100 is further subdivided into various parts. Again, each subpart of the bar represent the different components of a variable, but there is one difference here from the divided bar diagram that we have just discussed, that here the bar and its various parts are represented as the percentage value of different components and not the actual values. Okay, so first we need to calculate the corresponding percentages of each value, and then those percentage values are used for representation in the percentage bar diagram. So such kind of bar diagrams are also called as the percentage divided bar diagram because of its similarity with the divided bar diagram. Now, the percentage divided bar diagram is prepared in a manner which is very similar to the divided bar diagram. That is, the different components of one particular variable are represented as different parts stacked one upon the other in a single bar. So here you can see there is one representative percentage bar diagram given for you. One thing that you must notice that the length of all the bars are kept as 100. Okay, and then each of the data point, you can see here it represent one variable. So there are different years from 2009 to 19, and every year is again divided into all the 12 months. So you can see the different components of every year that you can see here with the help of these different colors are actually the different values obtained in every month. And the values that I am referring to here is the distribution of rainfall in different months of a year. Okay, so percentage divided bar diagram, I will again summarize for you that here the length of the bars are kept equal at the value of 100, and each bar is divided into different subparts that are representing the percentage value of the different components of each variable. Now, percentage bar diagrams are actually a very good method to represent the relative changes in the various components. Now let us try to understand how to draw a percentage bar diagram with the help of this example. This is actually the same data set that we used for divided bar diagram. Why? Because the method is very similar to that of the divided bar diagram. Okay, now let us understand this figure. Here again, you can see here just by looking at it, you can identify that it is a percentage bar diagram because each of the bar of this diagram is kept equal to 100%. Okay, now one thing that we need to keep in mind is that first we need to convert each value for every variable. Say 2013, you have 12 different values, so each of these values have to be converted first into a percentage value, and then you will represent it as a subpart of the bar. Okay, so first you will represent the value of January, and just above the value of January, you will represent the percentage value of the rainfall observed in the month of February in 2013. Okay, and so on, you will go on till the December, and in a similar manner the different percentage value of the rainfall obtained in different month will be represented for each of the different year. Okay, so again each year is being considered here as one variable and different months in the year. Okay, so rainfall obtained in different months of the year are the different components of this particular year. Okay, so this is a very good representation of a percentage bar diagram, and you can see here you can draw inferences also here that okay, in August you can very clearly see here that in August and July and August you observe the maximum rainfall, and that too in 2009 you can say that you observe the maximum rainfall in the month of August. So it becomes very easy to draw inferences, what I was talking about in the initial introductory part, and also to compare different data sets with the help of such diagrams. The fourth and final type of bar diagram are the multiple bar diagram. It is very clear from the name itself that multiple bars are used, but where, in what context. So here I would like to remind you of the divided bar diagram. Here again, in a similar manner, different components of a variable are represented here by multiple bar. Okay, so one important point that you must remember here, in case of divided bar diagram, different components of a variable are represented at different subparts of a single bar, but in case of multiple bar diagram, different components of one particular variable are represented as multiple horizontal bar which have been drawn side by side. So it is you all can have a look at this reference multiple bar diagram that is being shown here. So here, if we go by the definition, multiple bar diagram, two or more than two bars are constructed side by side horizontally for one particular variable or one particular period. This type of bar diagrams are also called as compound bar or cluster bar diagram. Why? Because we have clustered different or more than two bars together. Okay, now multiple bar diagrams are always a preferred method when we want to compare two or more variables, because it becomes very easy for you to compare different variables just at one look. Now, multiple bar diagrams have several advantages. One of the first advantage of using a multiple bar diagram is that it helps in easy comparison of the value of different variables. Okay, in a set, also within the variable and also between the variables. Both the comparisons can be done simultaneously here. Also, one important point that should be kept in mind is that different bars of one particular set must be of different color. Okay, why? Because it helps in to facilitate the easy comparison, but the same color should be kept for, say, one bar representing same variable should be represented in the same color throughout your bar diagram. Okay, that was what being represented in the last diagram that I have already shown. Now let us try to understand how to draw a multiple bar diagram. Here the data set that we have used for understanding the making of this diagram is number of rainy days per month in Delhi from 2009 to 2013. Okay, so here we have taken 5 months, data of 5 months. Okay, so here what we can do is for making multiple bar diagram on x-axis, each year is being considered as one particular cluster or one particular time period. So 2009, 10, 11, 12 and 13. So you have five different you can say variable, and then these 5 months becomes different components of this one variable. Okay, so you can see here that in 2009 we have represented these 5 months starting from May to September with the help of these vertical bars. Okay, and on top of that you can see the frequencies also being written here, which are the days of on which rain was observed in that particular month. Okay, so what the point that I mentioned in the previous slide, that in one particular set the different bars should be of different color. Okay, so you can see that different months are being represented by different color, so that makes it easy for you to compare that. Okay, yellow which represents August, is showing the maximum number of rainy days in 2009. Also, in different data sets, each bar representing the same variable, for example, August is being represented by yellow bar in each of the different year. Okay, that is what was being mentioned, because it facilitates easy comparison within the within one particular set also, and between the different sets also. Okay, so the multiple bars are in fact a very good way by which comparisons within and between different data sets can be made. Now, the third type of diagram which can be used for representing data is a pie diagram or a pie chart. Again, these are very popular diagrams to represent data. One important fact is that it is slightly different from the other diagrams that we have discussed. Okay, till now what we have discussed is bar diagrams where the frequencies or observations are being represented in the form of rectangular bars, but here in pie diagram, the pie diagrams are like a pie that is circular in nature, and this particular circle is being divided into several subparts or sectors which are representing the different parts or the different components of the data. Okay, so again, a representative pie diagram is being given here for your reference, and you can see here that there are different parts, subparts or sectors being divided in this pie diagram, and each of that is representing a different type of soil. So it is actually a distribution of major soils in India in percentage, and you can see here that different soils are being represented as different sectors of this circle. Okay, so area of these different sectors in a pie diagram is actually in proportion of the value of each of the observation that you are representing as the different sectors in the circle. So in order to make comparisons with the help of pie diagram, the pie diagram should always be made on a percentage basis, not on an absolute basis. What does it actually mean is that you first have to convert the values, the actual observation values, into percentages, and then start drawing the pie diagram. So, when you start making pie diagram, first take the different values of the variable or components, convert them into percentages. These percentages are then used to calculate the corresponding degrees of the sector in the circle. Okay, and then you will start drawing the different sectors of a pie diagram. Now, how to calculate the degrees? So this is very easy. There is a formula by which you can calculate the degrees of each subsector. So you just have to follow the given formula, that is component part, which is the percentage of your one particular component divided by the total value multiplied by 360 degrees. Okay, this will give you the degree of the sector, and then you can very easily calculate calculate the degree. Once you calculate the degree, you can easily draw the sectors of the pie diagram. Okay, now one limitation of pie diagram is that if you have very large number of components, it becomes very difficult for you to represent each component clearly on a pie diagram. So the pie diagram becomes less effective in that case. So only if you have lesser number of components, pie diagram is a very effective way of representing the data. Also, one thing I would like to mention here is that pie diagrams are a very good method of representing discrete data of qualitative characters or categorical data such as blood groups, age groups, expenditures, such examples. So when you have such a data, you can very easily represent each of the different subgroups as the subsector on a pie diagram. So, let us understand how to draw a pie diagram. So, there is a survey response for the effect of lockdown on physical health, and each of the responses have been, tabulated here for you. Okay, so how many of said that their health declined, how many said that their health in fact improved because of lockdown, there was no age, this was also a response, and then don't know. Okay, now if you want to use this particular data into the pie diagram, what you will have to do first, I said that you need to convert these values into percentages, then use that percentage to determine the degree and then calculate. Okay, one thing is here clear that if you add up all these, it will come to 100. Okay, so if there are 43 respondents for their health decline, then because the total is 100, automatically it will come out as a 43%. So for this 43%, using the using the formula for calculating the degrees, you will calculate the degree, and then you can see here that for every percentage different degrees are being represented as the different subsectors. Okay, and also in case of a pie diagram, you should provide a proper index here of because if you are representing it with different colors or different patterns, then it is very important to have a properly labeled index. Now, this concludes the different types of bar diagram. I hope you have understood the actual idea behind the diagrammatic representations and their importance. Thank you. See you in our third part of this lecture series, that is graphical representation of data.